Video number 188, graphing cosecant and secant function mother graphs. Let's take a look. In order to do cosecant, we must take a look at sine. So let's go ahead and take a look at that, obviously, because sine is equal to 1 over cosecant, and cosecant is equal to 1 over sine. Here we go. Here's the first quadrant. 0, 30, 60, 30, 45, 60, 90 degrees. There you go. There you have it. Cosecant is obviously what? The inverses. So sine 30 is 1/2. So cosecant 30 is 2 over 1. And so on. Okay, so you just reverse these, flip them over, and bam, there's the decimals you get. So what we would normally have for a sine would be 0, 0. The 90 degrees would take you up here. The 180 degrees would take you down here to negative, well, to 0. Then to 270 would take you to -1, and so on. And you would have this. Now, if we really analyze the situation and take a look in the first quadrant here, you would have 30 degrees would give you a half, 45 would take you here. This is your half for 30 degrees. There's your 45, and then there's your 60. So it takes you on that kind of quadratic type shape. And what would happen now is this. Here's what's interesting. Now this is sine. This is sine. I'm going to graph. Sine will be in black. We'll put cosecant in red. Okay. Now, let's go ahead and take a look. If you do cosecant, what do you got here? Zeros are undefined, right? Because that's the, basically, think about it, that's the inverse of 0. So you'd have an undefined, you'd have what? An asymptote. Because the 0 would be a value that does not exist for cosecant. Okay, it does not exist. Now your 30 degrees, instead of it being 1 over 2, it's 2 over 1. So you're up here. Okay, you're at 2 for 30 degrees. Okay. Then for 45 degrees, you're at 1.41. So you're somewhere around here, a little bit less than 1.5. All right. And then 60 degrees, 1.15. So you're closer to 1 down here. There's your quadratic shape. Look what's happening. You're getting this. And then at pi over 2, you're getting 1. So you're getting a shared point here, a point of intersection. Obviously, asymptote takes us this way. Now, this is what's happening in quadrant 1. Quadrant 2, you're going to get the same thing. It's just going to bounce its way back up. In quadrant 2, you'll be over here. 45. All right? Like this. Because you'll have an asymptote at 180 degrees. So then you'll have this. So this would be what would happen for cosecant. Then, guess what's going to happen over here? You'll have a shared point at 270, comma -1, right? You'll have another asymptote here at 360 degrees at all the pi's. And then you'll have a shared point when you go to 270 -1, but then when you go 30 degrees to the the reference angle 30, 45, and 60, it'll be -1.15, -1.41, -2, and you'll have this. Okay, the same thing going this way. So you'll end up with these reverses, these inverses of basically this quadratic that just simply got flipped over, and then anytime it touches the x-axis at all the pi's will be the undefineds. So you'll have undefineds, or do not exist, does not exist, at all of the n times pi's, all the n pi's. Okay, so this would be cosecant. Here's the next one, secant. Secant is obviously inverse cosine, so I guess we can kind of fly through this. Cosine, you get 0, 1, 30 degrees is root 3 over 2, and then you inverse it with secant, you flip everything over, and you get 1.15 here, 1.412, and you'll get it just simply at different places. So what you end up with for cosine is what? 0, 1, and then when we get to let's see here, 90 degrees. Just use our reference angle just to make sure. 90 degrees, cosine, comma sine, 0, 1. So then 90 degrees is 0, right? Then 180 degrees, I believe that's negative 1, right? That's negative 1, comma 0. So yeah, so you're over here. Then you're back up here at 0, then you're back over here. So remember, cosecant, or cosine was this one. Yeah. Yeah. So there's your cosine. Okay, so I guess this time I'm doing cosine in red, and this time I'll do secant in black. Okay, here we go. Now let's analyze the situation. Wherever there are zeros, inverting zeros would be undefined. There's a 0, that's an undefined. Okay, now what would this be? That would be a shared point. And then you'd have your 1.15, you'd have your negative 1.41, and your negative 2, and you'd go this way. So you'd basically have the same graph, except it would just happen at different places. Okay, and then we would have, where would our undefineds be? Our undefined would be at the pi over 2's, at all the 90s and 270s. So you'd have undefineds at pi over 2 plus n pi's. Right, 90 plus 180, 90 plus another 180 plus another 180. It'll just keep having you land on 90s and 270s all the time. So this is basically what would happen for secant, and we're in good shape. I would imagine you probably could compare. I guess maybe this be a topic for another video, but it looks like the graphs are virtually the same, except you would add or subtract 90 degrees to one of them. In fact, you could probably figure it out now. This would be at root 3 over 3 pi over 2 comma negative 1. This is 3 pi. This is pi over pi comma negative 1. So it looks like you could rewrite this and say that cosecant and sine are related as separated by 90 degrees. So, all right, guys, good times. Send me an email. Talk to you later.